Hi guys, this is the 2.4 and 2.5. So we're going to start with the 2.4, which is the reflections, and 2.5 is the stretches and compressions. So we're going to do that in the next video. So on this video, we're going to talk about the reflections. Obviously, you've hopefully remember from the vertical reflection on the x-axis, which you learned it in grade 10. So it actually looks like, for example, if you have y equals, let's say, negative 2 x squared, and then versus y equals just 2x squared, one looks like upside down, the other one looks like the smiley face, right? So we're going to deal with this one, we're going to review on this one at the same time. We're going to actually learn something more about the horizontal reflection on the y-axis. Okay, so let's take actually a look at the investigation. So we did this already in class, but I'm just going to go over again. So in this case, we have this graph. Okay, it's a function graph. It ends at negative 4 comma 1, and the other end is 3 comma 3. So based on this, we just need to look at where the line changes its, let's say, direction. So in this case, we have the x value of negative 4 and y value of 1, and then negative 2 and then 2. Then we have 1 and negative 4. Then last one is 3 and 3. So this is our original graph. Now, then let's take a look at what's going to happen if we do a transformation on it. So if we have y equals negative f of x, so it's basically the negative of whatever the original function is. Oh, forget about this part. Then what we do is we set up the table values to see what the outcome is like. So in this case, it's going to be negative of fn negative 4. Now, as you know, the fn negative 4 is 1 according to our previous one, so it's going to be negative 1. And the same thing goes, it'll be negative fn negative 2, but fn negative 2, we know that it is at 2, I believe, yeah? So then it will be negative 2. Same thing on negative f at 1, which gives me negative, then, well, remember f at 1 was negative 4, right? So it's at negative 4, which gives me positive 4. Lastly, negative f at 3 then gives me, well, f at 3 was 3, so it will be negative 3. So we have these coordinates for our transformed function. So let's plot them. So when x is negative 4, it's going to be at negative 1. When x is at negative 2, it is going to be at negative 2. When we have x as 1, it is at 4. And when we have the 3, the value gives me negative 3. So if we connect the dots according to the order, do not connect whatever the way that you like. Okay, make sure you follow the order. So we start from there and then go there and then come back down. So hopefully you can see this. If you can see it, it actually is the flipped version of the original one. So I'm going to put the red one along the original one. And hopefully you can see it, that this red graph is actually flipped along the x-axis. Okay, so hopefully you can kind of see that if you have the negative in the front of a function, that flips the graph along the x-axis, so it is the reflection on the x-axis. Now, then if we go to the next one, again, ignore this part, I forgot to get rid of it. So this one, let's try again. So this time we have f at negative x. So instead of putting x into the equation, we're basically putting negative x into the equation. So I have the x values here. So we have then f at negative 3, which gives me f at 3. Now, remember, f at 3 was 3 according to our original graph. We're still using the original graph. Now, what if it was at negative 1? So then f at negative 1 gives me then f at positive 1, which gives me negative 4. And same thing on, it's going to be f at negative 2 now, since x is 2, but we have negative x. So then it is f at negative 2, which gives me positive 2. Lastly, f at negative x, which is f at negative 4, right? X is positive 4, so it should be negative and then positive 4, which gives me negative 4. So f at negative 4, according to our original graph, it is at 1. So let's actually plot the graph and see how it looks like. then when the x is -3, so where's that -3? So when x is -3, our y value is 3. When x is -1, our y value is at -4. When x is +2, our value is at 2. And when x is 4, then our y value is at 1. So we draw the graph, and let's see how it actually looks like. So hopefully you can kind of see this. If you try to see it based on this red one compared to the green one, do you see that these are actually rotated sideways? That this point is now ending here, whereas this point is now ending there. So they actually switched it. Do you see it? So they actually flipped it along the y-axis. So that's the reflection on the y-axis. So hopefully you can see that the conclusion is when you have the negative sign in the front of the function, outside of the function, that will flip the graph vertically, so it is a reflection on the x-axis. And if you have the negative sign inside of the function, which is usually sitting in front of the x, that will give you the reflection along the y-axis. So the conclusion is then, if the a value, which is the value sitting in front of the whole function, is negative, that means it is a reflection on the x-axis. Okay, remember, on the x-axis means it rotates this way, okay? It means it rotates this way. Now, then if the b value, which is the value sitting in front of the x inside of the function, so in this case, this is my b, so in this case, b is -1. If the b is negative, then it gives me that it's the reflection on the y-axis. So this means that you're actually rotating the function sideways, okay? So remember this, okay? Remember this, it's actually very important. So let's actually try some or a couple of examples here. So if you take a look at it, we have the notation wise. So remember this, we have y equals a f at b, x minus c plus d. Now the c and d part we took care of it last class. We're trying to find here what's happening if the a and b are negatives. If the a and b are positives, nothing is happening. There's no rotation if a and b are positive. So in this case, we need to know how to write the function notation wise. So if we have the actual function. So in this case, we are going to deal with a and d, which is the a and d outside of the function, okay? Now, assuming that our function is x squared. So here we have the f at x going through the negative in the front and -3 outside. So what this means is that your transformed function can be written as this. All you have to do is see the f at x being the same as f at x. So this f at x can be replaced by this x squared. So it becomes negative, as I just have copied down the negative, x squared, which is basically f at x -3. I just copied it down, okay? Now, then same thing over there. Again, I have 3f at x plus 10, but we know that f at x itself is our x squared according to our if statement. So then it will be y equals 3x squared plus 10. Okay, so that was easy and simple. Now then b and c, which are the values inside of the function, okay, inside of the function that impacts x directly, is a little more confusing, so you may want to pay attention to this, okay? So then this becomes the y equals, now remember, f at x is x squared. So if I put f at, let's say, p, then this becomes p squared. If I put f at 2, this becomes 2 squared. So basically whatever I put inside of this bracket will replace whatever this x is. And the same thing over there. So in this case, I have negative bracket x plus 1 bracket inside of the outside bracket. So that means this replaces the x. So it will be negative x plus 1 and then squared. Now, one tip is do not expand this, okay? So do not expand. If you expand, well, you're literally just putting yourself into trouble, okay? Now, same thing over there. This is inside of the outer brackets, right? So the outer brackets are these. Hopefully you can see it. And this was supposed to be just an x before any transformations, but it is now replaced by -2 bracket x minus 5. So your function then becomes, which is the x squared in this case, that x in the x squared is replaced by -2 x minus 5 squared. Okay, so I really want you to try these two, okay, on your own and see whether you can do it. Obviously, you pause the video and then try it. Pause the video and try it. Okay, really, really need to. Okay, so hopefully you paused it, you tried it. Now, in this case, we have the negative outside of the function. So the y then equals negative. Now, f at negative x plus 1. Now, remember, this replaces the x, right? This replaces the x, the previous x. So it will be square root of, instead of saying x, it will be negative x plus 1. Now, then this plus 5 is done outside of the function, so it stays outside of the square root. The square root here is the function, right? So hopefully you get that one. Now, same thing over there. So we have the function which is 1 over x, but instead of having just f at x, we have negative outside. So our y then equals negative. Now, then 1 over. We don't have to change anything to the top because the top is just 1. It's not even x. Now, the x is at the bottom, but that's now changed to what's inside of the brackets of the new transformed function. So we basically just put that, okay, rather than the x. And then minus 10, because minus 10 is following the function at the end, so I just put minus 10 at the end. So hopefully you understand this. Now let's just look at what kind of transformations that were done in the A. So in the A, we have the very front negative, which is the A value. That gives me the reflection on the x-axis. Now then I see that I have negative inside of the function in front of the x. So this gives me reflection on the y-axis. Okay. Again, reflection on the x-axis means you rotate it vertically, and reflection on the y-axis means you're rotating sideways, horizontally. Okay. Now, then we take a look at the plus 1. So the plus 1 gives me the horizontal translation, right? Horizontal translation to the left, hopefully remember this, to the left by 1 unit. And then we have plus 5, so then we get vertical translation up by 5 units. Okay, so hopefully you understand this. Now, then B, basically the same thing. I have negative in the very front, so that's going to give me the same. So reflection, I'll just put short form on x-axis. I really want you to put the appropriate form on the test. I'm just putting the short form because I'm recording. I don't want the video to be too long. And then reflection on the y-axis. That's because we have this negative right in front of the x, right? This -2. And then we have horizontal translation to the right, right? To the right by 1 unit. Again, that's because we have -1 inside. Okay, don't forget. And then lastly, we have vertical translation up by, oh, is it up by? No, it's down by 10 units. Right? That's because we have -10. So hopefully we're okay. Now, as a result, how does the graph change compared to the original graph? Well, I'll say it's flipped, right? Flipped in both horizontal, horizontal and vertical. Then you moved to the left by 1, and then you moved up by 1. So that's how the graph actually looks like, right? This is more of a mathematical term or mathematical description. This is just a regular description of how the graph is going to change. Then same thing for the v. So for the b, I'm just gonna leave it to you. Okay, this one you can simply just do it on your own. All right, so hopefully you understood what's happening with the reflection. Okay, if you have any questions, let me know. Okay, bye guys.